In question 59, a tuning fork of unknown frequency makes 5 beats per second. Find its original frequency. So this is solution 59. So here velocity in air is given and length of the closed organ pipe is also given. So ultimately the frequency will be V over 4L. So 320 over 40 into 10 to the power minus 2, which will give us 200 Hertz. So there is 5 beats per beats in closed pipe. So frequency must be either 200 minus 5, that is 195 Hertz, or 200 plus 5, that is 205 Hertz. Now it is loaded, so frequency decrease. So by that it will be 195 Hertz. Sorry, 205 Hertz. Because if this is the original frequency, then we get 200 Hertz, that is decrease. And if this is the original frequency, then it will increase if 200 Hertz is there. So the original frequency must be 205 Hertz, so that it decrease up to 200 Hertz. In question 60, a piano wire A vibrates at a fundamental frequency of 600 Hertz. Find the ratio of tension in A to B. So this is solution 60. Now the frequency will be 600 1 over 2L root tension in B over 14 mu, and then FA will be 606 1 over 2L TA over mu. So the ratio will come out to be TB over TA over TB. So which will give us TA over TB to be equal to 1.02. In question 61, tuning fork is given. What could be the minimum length by which the wire should be shortened so that it produces no beat? So this is solution 61. So what do we have? We have the length, when the wire shortened, if wire is shortened, then frequency increase. So we know frequency is 1 over 2L root T over mu. So 252 equal to 1 over 2 into 25 into 10 to the power minus 2 T over mu. Let this be 1. And in similar way, L1 root T over mu. So dividing equation 1 and 2, we will get L1 to be 0.2431 meter after dividing 1 and 2. So, or it can be 24.31 centimeter. This is 61. So shortened by 25 minus 24.61, that is 0.39 centimeter. In question 62, a traffic policeman standing on a road. What could be the apparent frequency heard by a scooter driver approaching the policeman? Solution 62. Frequency will be given by u plus Vm minus V naught over V plus Vm minus Vs into the original frequency. So let's put all the values. 340, this is u, sorry, speed of wind, okay. Speed of sound in air, sorry, plus 0 minus 10 over 340 plus 0 minus 0. So it will be multiplied by 2 kilohertz. So after simplification we will get 2.06 kilohertz. In question 63, the horn of a car emits some sound. What will be the apparent dominant frequency heard by a person standing on a road in front of a car? Solution 63. Frequency will be given by this formula. So it will be 340 minus 0 plus 0 minus 0 over 340 plus 0 minus 5 into 2400. So frequency will come out to be 2436 Hertz. In 64, a person is riding a car with some speed. What frequency will be heard by another person standing on the road in front of the car and behind the car? So this is solution 64. So situation 1, we will have these values. Into 1250 Hertz. So it will come out to be 1328 Hertz. And in situation 2nd, we will have these values. Into 1250 Hertz. So this frequency will come out to be 1181 Hertz. In question 65, train is approaching a platform at a speed. The train passes with some with whistle on and without slowing down. What frequency will the observer hear after the train is crossed the platform? Solution 65. So here the apparent frequency is given, that is 1620 equal to 332 plus 0 over 332 minus 15 into real frequency. So f naught will be equal to 1620 into 317 over 332 Hertz. So the apparent frequency of train observed by the observer will be 332 plus 0 over 332 plus 15 when the train crosses, okay, into the original frequency, which is 1620 into 317 over 332. So after solving this will come out to be 1480 Hertz. In question 66, we have a bat emitting ultrasonic wave of sub-frequency. Find the two frequencies heard by the bat and the beat frequency between the two. Solution 66. So in this situation, what we will be having is that frequency received by the wall will be FW. For second wall, let it be FW2. 330 plus 0 over 330 minus 6, which will be into F, which will be 330 over 324 into F. and for wall, another wall will be 330 plus 0 minus 6 over 330 plus 0 plus 0 into FW2. So it will be 336 over 330 into 330 into 324 into F, putting the value of this. So ultimately it will come out to be 324 over 336 F. Three 36 over 324. In 67, a bullet passed a person. Find the fractional change in the frequency of the whistling sound. Solution 67. A part. So apparent frequency 330 over 330 minus 220 into F, which will be 3F. And B part, in this case apparent frequency after crossing will be 330 over 330 plus 220 into F, which will be 0.6 F. So let it be F1, let it be F2. So ratio of F2 over F1 will be 0.6 F over 3F, that is 0.2. So the fractional change is 1 minus 0.2, that is 0.8. In 68, we have two electric trains running at the same speed. If both whistles were 500 Hz and speed of sound is in air is 340 meter per second, find the frequencies heard by the person. Solution 68. So the figure will look something like this. The person will be here, one train will be here, one will be here, and the sound will be coming something like this. So let this be theta. So this will be V cos theta, and this is 0.5 kilometers. So 1.2 kilometers and 1.2 kilometers. So ultimately F dash 340 plus 0 over 340 minus V cos 22 degree, and F double dash second situation 340 plus 0 over 340 minus V cos 22 degree, plus V 22 degree into F. So which is 500, okay, F is 500, so it will be 529 Hertz, it will be 476 Hertz. In question 69, a violin player is there. Calculate the speed of the train and what beat frequency is heard by the player in the train. So this is solution 69. So here in the A part, the beat heard by the standing man is 4. So the frequency will be 440 plus 4, 444 Hertz. Or the another option is 440 minus 4, 436 Hertz. So 440, 340 plus 0 over 340 minus Vs into 400. So it will give us 3.06 meters per second, 11 kilometer per hour. And B part, the sitting man will listen less than 4 beats. In question 70, two identical tuning forks are vibrating at same frequency. We need to find beat frequency observed by the listener. So this is solution 70. So in this question what we will have is that the apparent frequency will be 332 plus 3 over 332 into frequency original, which is 256 Hz. 258.3 Hz will be the answer. And for tuning fork, 332 minus 3 over 332 into 256, which will give us 253.7 Hertz. So the beat will be 258.3 minus 253.7, that is 4.6 Hertz. In question 71, this figure is given. We need to find the number of beats heard by the listener. Solution 71. So according to the situation, 330 over 330 minus 5.5 into 512 and 330 over 330 plus 5.5 into 512, it will be 527.5 Hertz. It will be 510 Hertz. So the beat frequency will be 527 minus 510, which will be 17.5 Hertz.